Good morning, everyone. So, myself, Dr. Anju Mishra, and I'm Associate Professor in the Department of Information Technology in Ajay Kumar Garg Engineering College, Ghaziabad. And today, we are going to discuss on the topic of clustering techniques. So, as we know, clustering is the idea of grouping the data observations based on their similarities. And before we discuss on how we do the clustering, we first need to know that why we are actually interested in doing the clustering or following this method. So, for example, when if you have already gone through the previous video, you know that we have two types of learning paradigm. One is called as a supervised learning, and the other one is called as a unsupervised learning. So when we talk about the supervised learning, we are having the data set, and together with the data set, we are having specific number of the classes or the categories with us. So we are already having the labels that which observation is actually belonging to a specific class or to a specific category, right? But there are certain instances when we have the data set for which we don't have any kind of meta information. So there are some data sets for which we do not know that what kind of categories exist for that data set, and what those labels are, what these categories are. So in that situations, when we do not have any kind of labels together with the data set, in that case it is up to us that how we are going to make an analysis out of that particular data set. Now, as a human being, for example, if I ask you to analyze newspaper articles, for example, I have given you 10,000 newspapers, and I ask you to analyze what facts you can extract from this data. So now, as a human being, the basic approach that we are going to follow is to find out the similarity between the newspaper articles that we have with us, and then grouping the articles according to those similarities or those attributes. So for example, when I am talking about the newspaper articles data, I can find out that there are certain articles that belong to the criminal stories or criminal news. There are certain newspaper articles that follow the entertainment industry. There are certain articles that belong to the for example the about the financial sector. So for example, what was the stock prices were today in the today morning, and what are the current prices, and how the stock market is following what kind of patterns, whether it is increasing, decreasing, what was the previous days data according to that. So now I have found out that certain stories are having news related to the crime, and certain they are belonging to the entertainment industry, and there are certain news that actually follows to the financial aspect. So now I have found out that there are three clusters or three groups that I can make out of all these newspaper articles, and I can group the newspaper article belonging to one of these categories or the classes. Similarly, there could be a data set, for example, animals data has been given to you, and for if you are not aware about the labels of those animals. So for example, if I don't tell you that this is a cat and this is a dog. So for example, this kind of discriminative information is not present into your data, then how you are going to proceed? Of course, you will be finding out the similarity into the animal's shape, how many legs they have, how many eyes they have, right? Whether the animal is a furry one, or the skin is with a different texture. So based on all these attributes, you will try to cluster or group the data or the animals into different types of categories. So this type of scenario leads to the clustering techniques or the application of the clustering methods, that we have with us. So when the data set is unlabeled, right, in that case, we apply clustering techniques, right? And it uncovers the hidden patterns that we, previously have not known about the current data set. So this is one of the, advantage of using the clustering techniques. And when we apply the clustering, technique, it gives us more understanding of the present data which we have with us, and it helps in, easy analysis of the given data set for which we do not have any kind of, present information about what kind of patterns or the trends are present into that data. Now, when we talk about the clustering techniques, as I previously have said, that it falls under the category of unsupervised learning. So all of those problems where we do not have data with the labels, we say that they fall under the unsupervised learning problem, and sometimes we call this as the cluster analysis. Now, when we talk about the application of the clustering techniques, so when you apply the clustering, it reveals the subgroups in the available data set. So this is the one important property or the aspect of the clustering techniques. And inside the heterogeneous data, each individual cluster is homogeneous. So that says that, for example, when I'm talking about the animal data, for example, the animal data could have animals that belong to a vertebrate class where the vertebral column is present into that particular element, or it could be an animal without the vertebral column. So heterogeneity is one aspect that is crucial about the given data. But when we are applying the clustering, it will find out or uncover the groups of animals that are more similar or homogeneous to each other. So this is the basic concept. And clusters, they are basically groups of similar objects, as we already can imply from the discussion that we had till now. When we talk about the application of clustering into machine learning aspect, then machine learns the attributes of data by itself. So if you are creating a machine learning model that uses the clustering approach inside it, it means that now your machine is learning in an unsupervised way, and it is learning about the attributes or finding out the attributes from the data by itself. Now, there are several approaches for clustering that are existing, and each approach is actually suited to a particular data distribution. So what kind of data we have, commonly based on that we select a proper clustering techniques to be applied into our problem area. So I'm going to discuss here the four most common clustering approaches. The first one is called as the centroid based clustering, and this is one of the most popular category of clustering techniques that we have today. Then we have the density based clustering, distribution based clustering, and hierarchical clustering. So these four types of clustering techniques we are going to cover up in this video. Now, the first one is called as the centroid based clustering. So when I talk about the centroid based clustering, it is also called as a partitioning method. So we are going to partition the given data set into different clusters or the groups. Clusters means inherently the groups of data, and we are going to organize the data clusters around a central element. So this central element around which we are going to create a cluster or a group, it is called as a centroid. So what we mean by a centroid? So for example, if we have been given data like this, right, and suppose we took this point as the cluster centroid. So if this is the centroid, right, we will say that whatever data I have here, for example like this, I will group all this data into a cluster or into a group. And this group, how I am creating it, because this group, every element of this group actually is nearby to the cluster center. So this is one of the most important property when we are going to discuss about the centroid based method, that we are having a centroid which is a kind of a central element from the data set, and we are picking up this centroid as a random method, and then you are trying to find out the distance of the other points from this, centroid point, and based on the distance, we, try to find out how many elements are close to this centroid, and whoever, is close to this centroid point, we say that this point actually belongs to this cluster. So I can say that one centroid here actually presents or actually denotes one cluster or one group, right? In similar ways, we can pick, another, centroid. For example, if I'm choosing a central point here, and now I need to find out the distance of, other points from this point, and based on this distance, I'm going to take a decision whether the point is going to belong to this cluster. For example, if I say that this is the centroid number 2 and this is the centroid number 1. So for example, all these elements here that I'm depicting, those are part of cluster 1, and for this, again, I'm taking the decision based on the distance. So some distance I'm going to calculate between the centroid and the data points which are around it, and again, the point which is having a lesser distance will fall in the cluster of this centroid. So this is the basic method how we are going to do the centroid based, clustering. And K-means clustering, which you already have heard, right, is the one of the most, widely used centroid based algorithm that we are going to see later on in the presentation. Now, the centroid based algorithms, they are efficient, right? So we are able to, group the data sets, or sorry, data points into, cohesive clusters of the given data or the groups. Now, there are certain problems with this technique. So first of all, it is sensitive to the initial conditions. So how you are initializing, or how you are, selecting your initial cluster points or the centroid points, in fact, that is going to decide the final outcome. And the other thing that we need to, think about is the presence of the outliers into your data. So in the presence of the outliers, how we can apply this centroid based method, that we first can, clean the data and remove all the outliers from that, and then we can apply the centroid based techniques. That way you will be getting more effective results. Now the second strategy that we can use to cluster our given unlabeled data is the density based method. So in the density based method, as you can sense from the name, what we are going to seek from the data set, we are trying to find out highly dense areas from the data set. So when I talk about the density based clustering, we can have, for example, I can have certain points, right? So this way I can have certain points here, then certain points here, right? And as I can see here, right, visually even we can find out that there are certain elements that are present close to each other, and there are other points that are distant from rest of the points into this kind of data set. So if you are having a data set like this, right, how the density based method is going to cluster, that we are trying to find out the dense areas from the data set. So as you can visually see here, that this is one of the dense area, and this also can be referred to as one of the dense area. This is again can be referred to as the third dense area. So now we have to we have already find out 3 clusters here based on the dense areas, because there are 3 dense areas present into the data set. Now when we talk about the difference between the density based and the centroid based method, as you can see that in the centroid based method we are actually including each and every point of your data set into one of the clusters. So every point is going to fall in either the cluster 1 or cluster 2 or cluster K, like that, right? But in case of density based, techniques, there could be, certain points that will not fall into any of the clusters. So this is one of the things that we need to consider when we need to apply the density based method for clustering. Now, another, aspect here is that these techniques allow arbitrary shaped distributions. So what we mean by arbitrary shaped distributions? I mean, the group that you are creating, those cannot be circular, right? In case of centroid based method, we are almost getting circular or the oval kind of, shape when we are creating the clusters from the data set. But in this case, the shape is not actually, circular all the time. So arbitrary shaped, densities you can find out, and those densities, when you are clustering them together, those areas will be considered as, different kind of clusters that you have into your data set. Now, the difficulties when we are applying these techniques over the data set is that, first of all, the varying densities. So, for example, if your data set is having a lot of, different, density areas, and the density of those areas is varying. Varying means that somewhere you are having some clusters with less number of points, and somewhere you are having, very high, number of points that are too much dense, and they are present at a, specific space. Then, the final cluster groups will not be that much, consolidated. So we need to, understand that when to apply the density based method. And it actually is simple, that you need to first visualize your data set first, and then you are selecting the appropriate, the method for this. The second thing is that when your data is having very high, dimensions. So if your data is, high dimension, in that case, we most of the time are not using the density based methods. And another thing, or one of the, important characteristics of density based method is that it is not going to assign outliers to any of the clusters. So as you can see here, that some of the points which are not, part of any, area or the clusters, they can be considered as outliers here. Now, the third technique that we are going to discuss here is the distribution based, the technique, clustering technique. And as the name suggests, that we need to have certain kind of distributions present into our data set. So to apply this kind of, clustering approach, the first thing that I need to know about my data set is that what kind of distribution is present into that data set. So for example, if I already know that my data follows the Gaussian distribution or some other kind of, distribution, then I can apply the distribution based clustering approach onto it. And if you are not, aware initially that what kind of distribution is that, then in that case, we should not apply the distribution based, clustering techniques. Then we need to go for any other kind of, technique to cluster our, data set. Now, according to the distributions, so what we are going to do, that we need to find out different types of distributions, or different groups of distributions or different patterns of distribution that we have inside our data, and we are grouping the elements according to that. So this is the basic approach that is being used here in the distribution based technique. And as there is an increase in the distance from the distribution center, okay, it it will decrease the probability of the point belonging to that particular distribution or to the cluster. So you need to understand that, for example, I have certain points, right? And I know that, for example, this is one of the, kind of distribution I have. Now there are some other points like this, for example. This makes, another distribution for us, for example, right? So if a point, for example, like this, if there is a point like this, and if those points they are having, too much, distance from the center of these distributions, right? Then those points will not belong to that particular, distribution. So as we already know that each distribution is actually around the mean of the data set, right? So that way we are going to find out the distance of each and every point, and based on the distance, whenever minimum distance we are having, we are classifying or adding that particular point into one of the distribution clusters. Now another thing is that this technique is sometimes referred to as the model-based method, and as I already have discussed here, that when we do not know that what kind of distribution our data set is going to follow, or whether the data set is following any kind of distribution or not, then in that case a different algorithm for clustering must be used on that particular data set. The last type of clustering technique that we have with us is the hierarchical, and as the name suggests, when I talk about the hierarchy, right, I need to arrange the data set into a structure, kind of a tree structure. Most of the time we refer to is at a tree structure or a hierarchy structure that we are going to create out of the data sets that we have. Now what is the difference here? So in normal case, what you do, that you arrange the elements into a tree structure, but here, since we are performing the clustering, we are arranging the clusters into a tree structure. So that is the one important attribute of hierarchical based clustering, and it is also called as connectivity based clustering. Why? Because here we assume that the data elements present in the given data set, those are somehow connected to their successor elements or the ancestral elements. So it is a kind of when we are arranging the data as a hierarchy or as a taxonomy, for example, in that case you see that the classes or the categories that you put at higher levels of the hierarchy, and there are certain categories that you place at the lower levels or beneath those higher categories. So this shows a relationship of kind of containment. So we say that the lower class contains some properties of the higher class, right? So if that type of relationship exists into your data, the data can be clustered with the help of the hierarchical clustering techniques. So as I have said here, that any kind of taxonomical data that we have with us, right, whether it is a kind of for example, if you have been given a set of species data, so that have certain kind of relationship, because we know that some of the species, they are more related to the other species, and some have been evolved from the previous species, like that. So we can arrange those data, or we can cluster those data with the help of the hierarchical clustering technique. And any number of clusters can be chosen by cutting the tree at the right level. So this is one of the important aspect of this type of clustering approach. Every object is connected to the neighboring object depending on the proximity or the distance on the degree of relationship, and clusters are represented as dendrograms. So how we are going to represent the tree? So for example, we are representing one cluster like this, then we are creating the dendrograms, and with the help of these dendrograms we are arranging the subclusters, as I can say here, into the form of a kind of tree. Now additionally, what we can do, that we can assign x and y axis here. Okay, so I'm going to add an x axis and a y axis. So this is the x and this is the y axis, right? What we are representing here on the x axis. So at the x axis we are representing the data element or the cluster label. Okay, so what type? For example, if we have been given an animal data and we are arranging what kind of animal we are having with us into different types of, clusters based on their similarity and their connection to the previous, animal class. We are having here the animal class names, right? And on the y-axis, we are representing the distance here. Okay, so the distance tells us that how much one of the, cluster group is connecting with its lower or the, higher or, entity or the cluster. So that way we are representing the information here. Now we are going to discuss about the one of the most popular machine learning, clustering technique, which is called as the k-means clustering, and it is a centroid based approach and it is kind of unsupervised learning, example that we have. So when I talk about the k-means algorithm, there are two important things that we need to remember. One, that it iteratively determines the best k center points from the data set, and these k center points that I'm randomly choosing from the data set, those will be referred to as the k centroids, right? And the second thing is that we need to find out distance from centers, from cluster centers or these centroid points to the other data points. And based on the distance, whenever we are having, minimum distance from a given cluster centroid to a data point, that data point belongs to that cluster center. So these are the two important, steps that this algorithm follows. Now, one of the important aspects when we are doing the k-means clustering is that we need to pick the centroid location to minimize the cumulative square of the distances from each data point to its closest centroid. So it is not like that that we simply picking up randomly k data points and we will create the clusters. No, we are going to refine these cluster centers later on with more iterations. And why we are doing it? We are doing it to minimize the cumulative square of the distance from each data point to the cluster or the closest cluster centroid. Why we need to do this? Why we do need to do the refinements here? So refinement is required because we have no idea initially that which point needs to be taken as the cluster center or the cluster centroid. Okay, so since you are picking up centroids randomly, we need to refine those positions again and again. Once we are at a fixed position where your cluster centers or the points are not changing, in that scenario we will say that we will finally have found out these centers. So for example, how this techniques works, for example, you have certain data points here, like for example this. So I am having data spread like this. Okay, and now for example, initially I have selected this and this point as the three cluster centers. So this is C1, C2 and C3. Now what will I do? I will find out the distance from all these points present in the data set from cluster center 1, cluster center 2 and cluster center 3. So for example, if you have been given a data set like this, where we have been given attributes, for example, if one of the attribute is called as X, the other is called as Y. So X could be the X-axis value, the Y could be treated as the Y-axis point, and whatever data you have been given here, right, we are going to cluster it. So now once you have taken up your initial cluster centers, I'm going to make here more columns. So this one C1, C2, C3, and then finally for the label of each data point, that XY data point belongs to C1, C2 or C3. So this label is going to have that entry. Now what I'm going to do, that I'm finding out the distance between C1 and this XY point. I will note it down here. Then I will repeat the same process for the other points. Now I'm taking C2 as the cluster center, calculating the distance of each data point or observation from this, and then noting down here, right? So this I will do for all the cluster centers that I have chosen. Now once I have calculated the distance, then I'm finding out the minimum distance for each and every point. So for example, the second data points, maybe C1 is the minimum distance. For first data point, C3 may be having the minimum distance, and according to that, I will write the cluster labels here. So if I write C1 here, that says that the first point or the first observation of the data belongs to cluster center 1. The second one, sorry, cluster center 3. The second data observation belongs to cluster center 1 or cluster number 1, and that way I'm writing the labels. And then I will be, taking more iterations and refining the cluster centers actually. Okay, so this is one of the examples. So one of the important aspect of k-means is that you need to choose how many clusters you want to create. So this is something that you need to carefully, think about your data, that how many clusters you are going to do. The algorithm is not automatically going to create the clusters. You need to tell the algorithm how many clusters you want, and this is going to be set with the help of the k. So for example, if I keep k is equal to 3, we are going to have 3 clusters into the data. And again, as I already have depicted, you need to find out the distance between the points and the cluster centroids. Now, when I talk about the distance measure that is most commonly used in case of k-means clustering is called as the Euclidean distance. So we need to find out the Euclidean distance, and as you can see, I have taken 2 sample points. One is having 2, 2, and the other one is having 5, minus 2. So I need to find out the distance between these 2 points. Then again, from the 5 minus 2 point, I need to calculate the distance to other point. So I'm having 3 points here. For example, if I say that this is P1, this is P2, and this is P3, right? We are calculating P3's distance from P2, P1's distance from P2. For example, I have kept P2 as the centroid. So this way I am calculating the distance, and as you can see here that in first case I am getting 5, second case I am getting 2. So I will say that P3 is more close to P2. So that way P3 point should belong to this cluster with this centroid, right? So this is the basic strategy. This is the algorithm. So we need to first specify the number of clusters, that is k. Then we are initializing randomly the centroids from the data set, and we need to shuffle the data set so that we are clearly treating all the data points from the data set, and then we keep iterating until there is no change into the centroid value. So if your points are same in 2 consecutive iterations, we will stop the algorithm and those will become the final clusters, right? And once you have selected the centroid values, you need to compute the sum of the square distance between data points and all centroids. So this will help you actually into finding out the refining your centroid. So once you have done the initial clustering, and you will have the groups of data, right, for every group. Now what you are going to do, that you are taking average of all the points fall into this cluster, and this average will become the new cluster center. Okay, so now again you will be having 3 different clusters centers at different locations into your initial clusters, and now you need to find out the distances again of all points from these cluster centers, and we are again grouping the elements like that, and we will repeat this process until we are not having final clusters with us where the centered values are not changing, right? So this is the whole approach of k-means clustering. I hope that whatever I have discussed today will be helpful for you. Thank you so much.